Hi there, my name is Antonio Feregrino, and today I will talk to you about some common myths and some real problems of the Jupyter notebooks. The usage of the notebooks is one of the most divisive topics in the data community. Everyone seems to have strong opinions on them. At Ploomber, we know there are legitimate reasons to avoid them, but it seems that the conversation centers on the issues that are already solved and not on the real problems. But what are the real myths and the real issues? Let me tell you about them. You cannot version control notebooks. The IPYNB format is known to everyone that works with notebooks, but not everyone knows that under the hood is nothing else than a JSON file, where both code and output are stored together in the same plain text file. This is very convenient. You can work on a notebook, execute it halfway through, save it, and then come back the next morning and all your results will be there. And while it's very convenient for us, data persons, as notebook consumers, managing notebooks in a version control system such as Git is a complete challenge. Version control systems are made to store code that generates a result, and not the result itself. For example, storing the results of our Jupyter notebooks can increase the size of our Git repository over time. But wait, that is not so bad when you compare it to what one has to go through when trying to find the differences between one version of one notebook and another. Using Git DIFF, or even a UI tool such as the GitHub web interface, this is what we get. Fortunately, we can easily fix this issue. There are tools that make the task of differentiating notebooks easier, presenting a more pleasant user interface to do so. Some of them are just as easy as installing a Jupyter Lab extension that allows you to properly diff notebooks. Here is a view of how one of these tools looks like. You can clearly see the differences, right? Even the images differences are displayed. Under the hood, the extension I just showed you uses NBDime. NBDime is a CLI tool that even allows you to find differences from the terminal. You should check it out. A third option, and one I think you should consider seriously, is to use a tool called Jupytext, which is a Python library that allows you to open Python script as notebooks. In this way, you get the best of both worlds, interactive editing and clean Python code in the backend. Obviously, there are issues with this approach, since the output is effectively lost because a Python script can't hold any data. However, you can still keep your notebooks and use Jupytext to pair their code with a Python script. This will allow you to have two linked files, one that keeps the code and one that holds the output. You cannot test notebooks. As someone who spends most of its time making sure code works in production, this is one of the issues that is close to my heart. There are ways to test notebooks for sure. However, there are multiple approaches one can take. If we're talking about testing notebooks as a whole, we can use a tool like Peppermill to execute notebooks programmatically and then check on their results. If your only concern is that the code executes properly and you do not need to check the outputs, it is possible to use an even simpler command and execute this as a part of your CI system. Finally, you might be interested in unit testing specific parts of the notebooks, such as the functions that you define within it. Obviously, the best approach would be to define the functions in a separate Python script and import them. However, if the function is still in your notebook, you can use TESTBOOK, a tool that allows you to extract the definitions from a notebook and test them individually. You cannot modularize notebooks. Another criticism is that you cannot modularize notebooks. However, here's where Ploomber comes in handy, as it makes this process very straightforward. Say, you have 3 notebooks, one to load, other to clean, and the final one to plot the data. You can create a pipeline that executes them in order. The pipeline would look like this. And just as easy, run it with a single command. You should try it now by installing Ploomber, downloading a simple example, installing the requirements, and then just executing Ploomber build to run the pipeline. Once you modularize your notebooks, there is a world of possibilities. The notebooks that are modularized are easy to collaborate on, are easy to test, and can be executed in parallel. They are definitely far better than having a single gigantic monolithic notebook. While we're still in the topic of Ploomber, I would like to remind you to follow us across our social networks, as well as invite you to keep an eye on our blog, where you will find more insightful content just like this one. Just one last thing, we have a Slack group where we can answer any question you might have. Now, let's go back to talk about notebooks. So, what are the real problems? Given a notebook, we say it has a hidden state. When executing it linearly, it returns different outputs than the ones it was previously saved with. For example, the left notebook doesn't have a hidden state, because if you restart the kernel and run all the cells in order, you'll get the same results. In this case, the number 3. But the notebook on the right has a hidden state. If we restart the kernel and run all the cells in order, the final output won't match the recorded 42. We'll get the number 3 instead. So this one has a hidden state. Hidden state makes it impossible to reproduce our results. This problem is so pervasive that there is even a Nature post about it. You should check it out in the link. But not everything is bad news. We can ameliorate this problem with testing, as we have seen before. But this is not a full solution, since you may not notice that your notebooks are wrong until you test them. We might be too focused on our work and only realize that our notebook is wrong until the CI fails once we try to merge in production. An approach that is gaining popularity is the usage of reactive notebooks. Reactive in the sense that the cells are recalculated if anything they depend on changes. Remember our notebook? If I was running a reactive notebook and I edit the cell where I am assigning a equals 1, the notebook will automatically run both the third and fourth cells, as they depend on the value of a, effectively mitigating any hidden state we might be carrying inadvertently. There are certain tools, such as Pluto, that offers reactive notebooks for the Julia language. And there are some Jupyter commercial distributions that allows you to have this functionality. But if you don't want to learn Julia or you don't want to pay just yet for Jupyter, there are some open source solutions being worked on for the Jupyter we all know and love. But reactivity has its own problems. In many cases, some cells might be too expensive to be recomputed every single time a tiny detail of them changes, increasing user frustration when they find themselves changing a tiny detail and triggering an hour-long process. Definitely, the usage of reactive notebooks is something worth discussing. Code quality is by far the biggest problem with notebooks today. There is nothing intrinsic in the notebooks that leads to poor code quality. We all know that low-quality code exists everywhere, and it's not a Jupyter exclusive problem. What is going on is that Jupyter is democratizing computing. There is no longer any need to be a master of the terminal or an IDE full of buttons to perform a data analysis. All you need in many cases is just an internet connection and you're good to go. So, all of a sudden, we have plenty of people with non-software backgrounds working as data scientists across all industries. And that is a very fantastic thing. Everyone should have the opportunity to code and create value. Jupyter is just the entry door for many people to the world of computing. It really feels that as a community, we have failed to mentor those people who know a lot about statistics, machine learning, and domain knowledge, but don't have too much experience coding. The pervasiveness of low-quality notebooks are a consequence of the lack of processes to develop and deploy data analysis code. It is really true that the notebooks are the best way to explore and analyze data, and they do have problems that are worthy of discussion. At Ploomber, we believe that the notebooks are a crucial tool for data teams that deliver high-value solutions faster and quicker. We are working really hard to fix all the notebook problems to hit the sweet spot between powerful interactivity and the reliability of a well-defined development and deployment process. Join our community on Slack to keep the conversation going, and follow us on our other social channels where you will find more valuable information about data science and all the processes that aim to make it better for everyone. See you in the next one.